I'm Seann Gardiner with Weights and Biases. Hopefully, well, I moved to the first slide already. I lead partnerships here. I also lead a lot of our go-to-market. When I saw I was last, or almost last, presenting today, I was going to make the joke of, I'm the only one standing between you and the bar, but I see that's not a joke I can make today, which is great. So I like this conference already. So who is Weights and Biases? I can't go back on these slides now, but we call ourselves a developer-first ML ops platform. We really make the best developer tools for machine learning. So many of you might have heard of Weights and Biases. Your team might have used it, but what we're seeing in the market is that ML is transforming almost every industry, and we work with thousands of different ML teams. We see the likes of John Deere using computer vision to build fully autonomous tractors to do precision spraying of herbicide. Microsoft, in their health ventures, is doing some amazing work around disease prediction. And even in sort of more blue chip industries, companies like RBC up in Toronto are using reinforcement learning to do automated order execution. So, we're seeing thousands and thousands of use cases, and we're living in just an incredible time. I mean, if you've been following what's been happening with like DALL-E 2 or Stability and all of these large language models, I mean, we just live in an incredible time, and it's just going to drive so much change. A bit of background on Weights and Biases. We started the company 6 years ago. We've raised a couple $100 million in funding, and we really started the company to, help machine learning practitioners with a set of very useful developer tools to be able to build largely deep learning applications. And Lucas and Chris had started Figure 8 before. We have a lot of angel investors, people who wanted to invest in the company from some of the leading companies doing ML, and we built a great team. And the problem that we solve, and the problem that we sought out to solve, is if you look at developing software, there's a pretty tried and tested workflow to be able to develop software. You use Figma, you use GitHub, Jira, etc. When you're building ML or when you're teaching machines, to write software, there isn't that workflow, and it takes a very different workflow, right? Because you're using data to be able to train models, do representation, and then get those models into production, and then constantly retrain them. And so with Weights and Biases, when we released the first product, and anybody here can go and download and use the product, we really started in experiment tracking and optimizing models. And now we've sort of broadened out onto the data management side and also onto the production side. And we have 400,000 folks today who have signed up and use Weights and Biases. We give it for free to anybody in universities and research teams. And we have a lot of enterprise customers, which we can talk about as well, and they love the platform. So every day, we see many of these companies, come in and start to use our platform. And, what they do with the platform is really collaborate around machine learning, because there's a lot of data that you want to track and metrics, and then you want to be able to share those metrics. And so we have a significant number of customers. We have a lot of folks in the AV space. I think 4 of the top 5 auto companies are using W&B. And then, a lot of companies who aren't necessarily ones you would count as sort of tech companies, right? Folks in retail, folks in banking, etc. So one of the things we sort of pride ourselves on is, how interoperable we are. We're really an API layer that can be deployed in any cloud. We have our own multi-tenant cloud, and we plug into all of the different sort of frameworks. So if you go to Weights and Biases website and you go to our community and you start to use the platform, we have pre-done integrations with all of these frameworks: PyTorch, Keras, TensorFlow, JAX. And I didn't prepare this presentation following Jan's presentation, but I think he mentioned every one of those frameworks. We're cloud agnostic and we're hardware agnostic. You can also deploy us in a container on-prem. So we fit into your environment. We fit into sort of the surface area of that environment. And we help your ML teams build better ML. And we're super excited about being able to partner with Edge Impulse. This is sort of where we fit in, and I think Seann showed a very similar diagram. But when your teams are developing models, when they want to collaborate around ML, using weights and biases allows them, one, to be able to track everything that they're doing, to be able to optimize those models, and to be able to get a ton of visibility into what they're doing. One of the most amazing stories, we had a customer, it's one of the top race teams, so if anybody watches Drive to Survive, I'm not going to reveal their name. They started using weights and biases, and they wanted to virtualize sensors on their cars and to be able to win the championship that's going on right now. And they found things that, with all of the ML tools that they're using, they couldn't find just because of the granularity of data. There's a lot of that getting spit off the car, coming into weights and biases that they can go and use. So, they started using it, they ended up buying a license, being able to deploy it, and now they've deployed these models, into production. And so, we're super excited. A lot of our customers are pushing these models to edge devices, to vehicles, et cetera. And we're just becoming that fundamental tool chain, and we're really excited about putting this in the hands of Edge Impulse customers. To get up and running, and I'm going to invite my colleague Karan up to give you an overview of what we've developed. We'll also give you a link to that report. But literally with a couple lines of code, you can get started with what we're doing. And start to track all of the ML that you're doing and collaborate around it. So with that, I'll hand it over to Karan to show you what we're up to.
Awesome. Yeah, thanks, Sean. So today, this won't be like a live demo, given the setup. I'll definitely share a link to the report. But what I'll be doing is highlighting some key areas and features that weights and biases provides. And then once you follow that report that I'll share at the end of this presentation, you can see and play around with the platform. It also has some links to getting started. But in terms of, I would say, key concepts and key areas, how weights and biases fits in. So I would just like to reiterate this slide. You just saw it a couple of minutes before. And even Seann described this slide. This would be the continuous learning loop. So where weights and biases fits in is we are a lightweight integration, where we would sit on top of your machine learning workflows. So what we'll do is we'll help you track all of the things that you're doing, something which is quite tedious for a machine learning engineer. So we'll abstract all of that for you and save time, so you can focus on the real work that you're tasked to do, which is getting the best models out and worrying less about how to maintain all of those things, document stuff. And all of that is done by just a simple integration. So now, when it comes to connecting Edge Impulse to weights and biases, right? So let's say if you have any edge device that you would want to build, that you're gathering data from, and you would want to build a machine learning model. This is, I would say, a basic setup. It's a very simple, I would say, installation. So you definitely need both of these accounts. So that way, you can have your own API keys to pull data as well as push data. And the report that I'll share has these set up in detail. So you can follow along. You can parallelly work on your own projects. But for the purpose of this demo, the project that we will be working on was the bird sound classification dataset. So this dataset is already in Edge Impulse. So if you would want, you can use this boilerplate dataset. But it can be pretty much any dataset that you gather from different edge devices that you want. For this specific dataset, this is for an audio file. This is just a very basic dataset trying to classify the birds based on their sounds. So what we did was, in the previous slides, the steps that I showed, we just used that and pushed that data from Edge Impulse into weights and biases tables. So when I talk about tables, it's just like a pandas data frame. But now it also has support for all of those rich media types. So things like images, audio files, video files, 3D data, molecular data, pretty much anything that you would want. You can just have one view, wherein you can have your structured data along with that unstructured data. And this is just a screenshot, but if you go on that report, you can actually play and listen to each of those audio files. So that way, I think this goes more towards explainable AI. So once you have your model that's training in, you can visualize, hear those sample audio files, see what the ground truth is, see what your model is predicting, and then try to understand, is it behaving in a certain way that you expect? If not, you can now drill down and see why and where is it that the model, where you can improve on that model. But yeah, going back to this data set, you can see there are some examples of sound files, for some birds, there's a snippet of a house sparrow here. At the same time, we also have some noise in this data set. So it's, I would say, a classic data set wherein you need to work on feature engineering, make sure your model's not getting biased because there's a noise introduced. At the same time, when it comes to sound, it can be broken into multiple features, and there can be so many different features. You would need to make sure your model incorporates the best set of feature so that it does not get confused with the other underlying features, which might decrease the training accuracy or might result in a completely random output when you're trying or testing it out on an unseen data set. So in order to do that, when it comes to different features for audio files, so what we did was performed hyperparameter tuning. I think that's the best or the classic way, where you can easily filter out the different sets or the different combinations and see which works best or not. In this case, we performed hyperparameter optimization on weights and biases, which is called as sweeps. So what sweeps does is it has the ability to ingest that huge volume of data. So let's say if you have a super big set of hyperparameters, you can easily ingest that, run your model on top of it. And it's basically a two-step process. So the first step is just like with pretty much any hyperparameter optimization model, you would define a config file. A config file includes things like your the boilerplate machine learning framework that you're training on. At the same time, the different kinds of search strategies that you want. So do you want to consider a random search? Do you want a grid search or any method that you would want to choose? And then you can define the bunch of different hyperparameters that you want to optimize or get the best combination of. So you can define categorical values. So for things like your optimizers, when you can have different optimizers, you can have categories that you can define. Or let's say for some of those numerical values, you can also define in a range. One example would be learning rate. You can just define the minimum and the maximum range that you would want to be considered for this hyperparameter optimization. And you can see in this diagram here, all of that config file is stored in that central sweep server within the weights and biases platform. Once you're good with that, I think that's when you get into the next step, is while you're running in those agents. Agents is basically, I would say, a single experiment that you can run. And it will take a combination based on the search strategy that you have defined. And what you can do is you can run multiple agents in parallel. So that would basically make sure your process is achieving those results much, much faster. And as and when these agents are running in real time, you can see a visualization or output of these agents. And this will look something like this. This can be quite confusing and overwhelming at first, but this is what we call as the parallel coordinates plot. And the basic interpretation of this plot is all the vertical axes that you see, so things like the dropout, the activation, all those different vertical axes are the hyperparameters that you have initially defined as a part of the config file. And then the rightmost column would be your end goal that you're trying to target or that you're trying to optimize. In our case, we are shooting for a validation accuracy. So naturally, the highest value of validation accuracy corresponds to a better performing model. So now once I know what this graph means, what I can do is I can easily filter out on these graphs. So let's say I'm only interested in the parameters that result in the best performing model. So what I can do is I can easily create a filter on just my validation accuracy. And now this becomes a game changer. This would save all the time that we have seen machine learning practitioners have spreadsheets. You'll look at those spreadsheets, try to see, which I'm sure would take plenty of time, even more than a day or few days. This would be within few minutes, you can make some very clear observations. Some of that is, you can see like my Gaussian unit and my ReLU activation function seems to perform, like outperform the other ones. Or similarly, I can see my G-flops is associated with my kernel size, which would make sense. So what I can do is, using some of these observations, in my subsequent hyperparameter tuning or in my subsequent sweeps, I can just narrow down that range. So let's say in my second iteration, I can only choose to have just the range that I see in here. So similarly, when I'm iterating on this, I can eventually narrow down my search and get to that best set of hyperparameters, which I know would result in the best performing model. So this is how you can easily achieve optimum results with weights and biases sweeps. That's just one way of how you can perform hyperparameter optimization. Along with that, while you're training in, like machine learning is an iterative, it's always iterative because you're constantly trying to improve and improve, as in when the new data sets is coming in, the models become, you need to train them so they correspond to the newer data that's coming in. So at the same time, while you're tracking in experiments, you can create a bunch of different dashboards within weights and biases. Like one such snippet is this particular line graph, wherein you can compare, I think this is comparing validation precision, but pretty much anything that you want. So it gives you better explainability as well as interpretability on what's happening in your machine learning workflows. So let's take this particular example. Here you can see for one particular line, I see there is a sharp dip. So what I can now do is, I see there's something that's not working, or probably there's something that's going bad at that particular step. I think it's step number 30. So now what I would want to do is traverse back and see like, where in my entire project lifecycle can I improve to make sure like, my accuracy or my precision is always getting better, and I can keep improving. You can only do that if you have a lineage or if you have some place where you have stored all of that data. And that is something weights and biases artifacts is helped to design. So what weights and biases artifacts does is, it's basically, I would say, that system of records where you can store pretty much anything that you would want for machine learning. So this is like a GitHub, but it's not just for code. It can be like for code. It can be for your data sets, any kinds of data sets, as well as for your models itself. So what artifacts will do you is, it'll automatically version all of those different components that you would want to keep a track of. At the same time, it'll give you that lineage view. So the graph that you're seeing on the right, it's basically giving you that lineage view, which shows you all the different steps involved in your machine learning project. So let's say going back to the previous diagram, wherein I see something is not working well, like my model's not performing well, I can traverse back through this graph, and now I can pinpoint to that exact set of operations and narrow down like the final result or the final cause. Like, is it because I don't have enough data sets? If that's the case, I can go back and collect some more data set. Like, do I need to change my machine learning training framework, or what that result may be? So with that, I would say lineage view, you can easily trace back and get to that root cause. And anytime like there is anything, so let's say there is a bad data set that's introduced, you can again go back to that exact version of that code. Because as you're iterating, you end up creating like multiple different versions. And over a period of time, like when it comes to reproducibility, it becomes very difficult to track. Like, was it version 10 of my code that I used? Like, was it the version 100? And it basically takes a lot of time. Like, probably we have seen some customers, it has taken weeks for them because it wasn't well documented. But now I think with this lineage view, it's just like one click, you can just trace back and recreate that exact steps, and then make some changes or optimize or do whatever that you would want to create like better performing models. So these are just, I would say, like a quick snippet of some of the features that weights and biases offers today. So what you can do is going back to that continuous learning cycle while you're training in your models. So let's say you pull that data from Edge Impulse. You can keep training, keep iterating on that. You can have like weights and biases sit on top of this, like track all of those metrics, give you that results. And then once you're good with a certain model that you would want to eventually push to production or push to that edge device, you can go back to that loop, like test out that model, and then push it back to that edge device that you want. And this continuous cycle it is a constant cyclic cycle that you can constantly keep a track of. And as I mentioned before, I think this QR code is a link to that report, which basically walks through all the steps that I talked in very much detail. So let's say, like, if you would want to just recreate this bird sound classification project, you can just follow along the steps, or like for your own project, you can just follow this particular report. It also has links to some getting started code. So like, feel free to give this a try and like, reach out to us like, if you have any questions or if you need any help with anything. As Sean mentioned before, like weights and biases is like free to use for like, academics and research work. So anytime you would want to give it a try, I think this report can help you, and it has all the documentation links. So with that, thank you so much for having us, and yeah, hope you have a great day.